Hello, we're Guild 2 and this is Phase 2 of our group project. During Phase 1, we developed the problem statement, how might we ensure access to safe, clean, and reliable drinking water to those in northern and remote communities in Ontario? Our group then used the KT method to revise our initial problem statement. In the situational appraisal stage, we clarified our priorities, which were clean water for the end users and an end to boiling water advisories. In the problem analysis stage, we identified the root causes. On the right, you can see a bar graph from a recent publication that shows the major causes of water advisories among First Nations communities in Ontario. In the decision analysis, we did additional research and selected the three most common causes. The primary causes we found were issues with equipment, such as neglected water treatment systems or corroded pipes, inadequate disinfectant residuals, like chlorine not being sustained with at least 1 part per million, and issues with turbidity, which reduces the effectiveness of water treatment. In potential problem analysis, we found that it's important to understand the relationship between weather and hydroclimate variability, the need for maintenance, and recognize that different impurities in communities may require varied responses. All of this led us to revise our problem statement to be, how might we ensure adequate disinfectant residuals in the drinking water for remote First Nations communities in Ontario? We've come up with three potential solutions. The first is reducing the turbidity of water during the summer months to increase disinfectant residuals through sedimentation and filtration. The second is using chloramine residuals instead of free chlorine, as it has a longer disinfectant residual stability. The third is replacing corroded piping and focusing on moving water sources over stagnant sources to reduce nitrification and microbial growth and maintain disinfectant residuals. To evaluate the potential solutions, we created a set of 7 criteria that we considered important. They are cost, speed to implement, sustainability, maintenance, desirability by community, proven history of success, and adequate capability to implement. Here you can see our decision matrix with the weighting we decided to give each of our characteristics and rated for each of the 3 choices. Through discussion with Dr. Gora and further investigation, we found that often the advisories based on turbidity are issued as warnings rather than due to poor water quality. This helped further solidify for us the use of chloramine instead of free chlorine as our favored design solution. We came up with a few parameters for success. Initially, we set a goal of 50% overall reduction in drinking water advisories, but we believe it's better to approach this on a community by community basis and have a model that is generalizable to other communities once proven successful. We want the end users to be satisfied with their water quality, and we want the water to be in line with standards set by the federal and provincial government. Thank you.